When you picture an airplane, you probably imagine something symmetrical, a craft balanced and gliding smoothly through the sky. Since the earliest days of flight, this design has felt like the obvious choice. Balance equals safety, right? Well, in the vast realm of engineering and physics, what seems obvious isn't always the case. And the world of aviation is full of surprising twists and turns, much like the path of an airplane through the clouds. In the mid-1900s, aviation was soaring to new heights. Commercial airplanes were becoming larger and faster, and supersonic flight was no longer a distant dream. It was a tangible goal. This era marked a significant leap forward, much like the Easton maneuver in gymnastics, a daring move that defies expectations and showcases incredible skill. But amidst these advancements, a nagging question persisted. As planes raced towards the edge of the sonic barrier, could they do so without sacrificing stability? Enter Max Monk, a Hungarian-American aerospace engineer whose name echoes in the corridors of aviation history. He was a pioneer in the field of aerodynamics, a man who saw challenges where others saw roadblocks and possibilities where others saw impossibilities. One day in his cluttered office, filled with scribblings and model airplanes, an idea struck him like a bolt of lightning. Why not design an airplane that could fly at supersonic speeds while maintaining stability? You might ask, why didn't anyone think of this before? Well, because conventional wisdom held that stability and supersonic flight were mutually exclusive. It was like believing a bird couldn't fly backwards and forwards at the same time. But Monk saw things differently. In his mind, he sketched an airplane that defied convention, a plane with wings that sat at an angle, wings that wouldn't fit together if placed symmetrically. His idea was audacious, almost heretical in the world of aviation. It went against everything engineers had been taught, just like a trapeze artist defying gravity. But Monk wasn't done. He didn't just draw the plane. He analyzed it, calculated its movements, and simulated its flights. He wanted to prove that this seemingly crazy idea could work. His calculations showed that an aircraft with asymmetrical wings, which he named the oblique wing, could maintain stability at supersonic speeds. But proving it on paper is one thing. Bringing it to life is quite another. The skepticism was palpable. His colleagues, some of the brightest minds in aviation, looked at his designs and shook their heads. It was too unconventional, too risky. But Monk pressed on undeterred. He knew that great discoveries often meet with skepticism, just as a painter showing a cubist masterpiece would have faced ridicule a century ago. Finally, in 1952, Monk's perseverance paid off. He received approval to build a small-scale model of his oblique wing plane. Soon, in the wind tunnels of NACA, now known as NASA, the model took shape. It was a tiny replica, a mere fraction of the size of a full-fledged aircraft. But in this miniature lay the seeds of a revolution. When the model was placed in the wind tunnel, the results were nothing short of spectacular. The oblique wing performed better than anyone had imagined. It glided through the air at supersonic speeds without breaking a sweat. Stability wasn't an issue. In fact, the plane seemed to dance with the air, each movement fluid, each turn graceful. The data from the wind tunnel provided irrefutable proof that Monk's concept worked. It was like watching a tightrope walker defying gravity, except this was a plane defying the very laws of aerodynamics. The news spread like wildfire through the corridors of NACA. The quiet hum of the wind tunnel now echoed with excitement. Monk's breakthrough had opened up a Pandora's box of possibilities. But as with any groundbreaking discovery, the question of practicality loomed large. Could this laboratory marvel be transformed into a full-size aircraft? The transition from theory to practice is often fraught with challenges, much like the final moments of a figure skater's routine, where every movement must be precise and flawless. And while the wind tunnel tests were successful, the road to building a full-size oblique wing plane was long and bumpy. The concept was sound, but turning it into a tangible aircraft required overcoming numerous obstacles. Aerodynamicists had to refine the design. Engineers had to modify the construction techniques, and material scientists had to ensure the plane's structural integrity. The challenge was immense, akin to taking a beautiful painting and transforming it into a three-dimensional reality. Each step of the way, naysayers emerged, pointing to new hurdles, questioning if the plane could really withstand the stress, if it could maintain stability during takeoff and landing, and if it could navigate through turbulent skies. But the team at NACA was undeterred. They had seen the potential of the oblique wing, and they weren't about to let it slip through their fingers. Years turned into a decade, and the project continued to evolve. Tests, modifications, and retests became the order of the day. Finally, on May 23, 1963, after nearly a decade of hard work, the first full-size oblique wing aircraft took to the skies. It was a Northrop XB-70 Valkyrie. The moment the plane soared into the sky, the skeptics fell silent. The flight was a resounding success. The oblique wing plane, this radical departure from conventional design, proved its doubters wrong. It flew smoothly, stably, and efficiently. It was like watching a ballet, a perfectly choreographed dance between the aircraft and the sky. Over the next few years, several more flights were conducted. Each flight brought the team closer to perfecting the technology. The XBT-1, the YF-27, and the F-15SDL all took to the skies, showcasing the versatility of the oblique wing design. But as they approached the finish line, fate intervened. The XB-70 suffered a catastrophic accident during a test flight, killing both pilots. This tragedy overshadowed the project and led to its eventual cancellation. Was this the end of the oblique wing story? Not by a long shot. The concept had taken root, and its time would come again. Today, the story of the oblique wing takes on new meaning. We stand at the cusp of another aviation revolution, driven by the need for speed and efficiency. The era of supersonic flight might still be a distant memory, but the future holds exciting possibilities. Aviation engineers are dusting off old ideas and infusing them with new life. Concepts once dismissed as too radical are now being reconsidered, and the oblique wing is leading the charge. Its unique design offers an enticing solution to the dual challenges of speed and efficiency. But it's not just about nostalgia or revisiting the past. It's about innovation, about finding new life in old ideas. Aviation, like many fields, tends to follow trends. One era is dominated by swept wings, another by composite materials. But the oblique wing remains timeless. It doesn't chase fleeting trends. It focuses on fundamental principles, stability, and efficiency. The trend today is towards blended wings, flying wings, and other bold configurations. But the oblique wing stands out as a beacon of simplicity and effectiveness. It reminds us that in the quest for innovation, sometimes the simplest solutions are the most effective. The resurgence of interest in the oblique wing is driven by necessity. As airlines seek to reduce operating costs and increase efficiency, the oblique wing presents a compelling solution. It's like discovering a forgotten tool in your toolbox that turns out to be exactly what you need for the job. But it's not just about the present, it's also about the future. As we look towards a world where air travel is more sustainable and efficient, the oblique wing design seems almost prescient. It is as if the engineers of the past had foreseen our future challenges and had already developed a solution. Embracing the oblique wing is more than just a technical decision. It's a philosophical shift. It's about recognizing the wisdom of past generations and adapting it to our current needs. It's like finding a vintage sports car, restoring it to its former glory, and driving it on the roads of today. The oblique wing embodies this philosophy perfectly. It's a blend of old-world craftsmanship and cutting-edge design, a testament to human ingenuity and our ability to adapt. So as we look towards the future of aviation, let's remember the lessons of the past. Let's not shy away from unconventional ideas. Let's not dismiss what seems too different. Let's embrace the strange, the unusual, and the unexpected. After all, the future of aviation might just lie in the past. As the sun began its slow descent, casting long shadows across the tarmac, a sense of anticipation hung heavy in the air. It was a moment pregnant with possibility, a testament to human ingenuity and the relentless pursuit of progress. The crowd of engineers and onlookers held their breath as the aircraft, a marriage of old-world charm and cutting-edge design, taxied onto the runway. This wasn't just a plain pit, it was a symbol of a philosophy, a belief in the power of revisiting the past to shape the future. With a powerful roar, the engine of the oblique wing aircraft came to life. The sound reverberated through the assembled crowd, a primal response to raw power. It was a sound that had once heralded the dawn of a new aviation age, and now it did so once again. As the pilot advanced the throttle, the plane surged forward, gathering speed with each passing moment. It was a sight that defied convention, a vision of the future taking shape before their eyes. And then it happened. The aircraft lifted off. leaving the ground behind in a trail of dust and exhaust. It climbed steadily into the azure expanse, its ascent a graceful arc against the backdrop of a setting sun. It was a moment that transcended engineering. It was a triumph of human endeavor, a celebration of progress, and a salute to those who dared to dream. As the applause subsided, replaced by a profound silence, everyone knew they had just witnessed more than a successful flight. They had seen a rebirth of an idea, a vindication of the belief that sometimes the answers we seek lie hidden in the echoes of the past.